Hello everyone, we're going live today. It's going to be our first inaugural live stream about the ReScript Retreat. Hopefully I will find some time like showing the crowd here. Everyone is super excited, working on the ReScript language. Hey!
Yeah, cool. I think I'll continue. I wanted to hear some voices and cheers from the people being offline compared to me. But yeah, nice to be part of this ReScript retreat.
And super awesome to have you as our first speaker. Dimitri is going to talk about Suri or ReScript schema. Super excited to have him tuning in via Zoom. So yeah, and I will hand it over to you, Dimitri.
Yeah, cool. So I'll start, and yeah, my talk will be about Suri or ReScript schema, the library I'll develop, and the main attention point, like the main the main reason this presentation exists is to eliminate the buzz factor currently the library has and start building it together. For example, how ReScript moved from like a few maintainers to like a project which is maintained only by community. I think it would be amazing to have something like this for Suri or ReScript schema. So let's move to the next slide, and I'll talk a little bit myself. So I work at Enovis Jonah Press, like really excited to work with this person. We've built, I think, the second or one of the biggest ReScript public projects on ReScript. I think this pupil study or something like this might be bigger, but still quite a big ReScript project. And yes, I'm a creator of ReScript schema, or recently renamed to Suri. Created something like 4.5 years ago, so it's quite an old project. Yeah, and a lot of people use this, and some people have issues with recent versions, and I promised them a new release already for a year already. And yeah, this is a reason this talk exists. And it started with Christoph's suggestion to do something, to change something. So yeah, Christoph waits for a new release for quite some time. And yeah, it was the main driver of this talk. Also, I have other people, like for example, Chen Lu from Midjourney, like quite a big name. They use Suri and they also need a new release. Gabriel, I think you don't use it in production, but you had some experiments with JSON schema and wanted some support there as well. Even we at Envio want a new version of Suri to support more advanced use cases, which we lack, but it's not there. And yeah, quite many open issues. And I think this is a problem of library, which is quite fundamental and like it's an important building block of potentially many applications. And yeah, to continue, I'll talk a little bit about Suri and why it is important, because there are quite many use cases for it, since it kind of prints your types into runtime. And then you have your types or data structures, like the main building blocks in runtime. You can make quite many things with it. So for example, right now we use it as like REST API definition to like perform like HTTP request, implement Next.js server with types. We use ReScript REST, and like as this is not supported in latest versions of Suri, so we are still on ReScript schema version 9, while Suri is version 11, for example. Also, like we use it for env reading. Like I've built quite a big library for Stripe as a code, a solution. Like it uses ReScript schema as DSL. Actually, ReScript schema, I think, or Suri, one of the best libraries for DSL, and I'll explain later why. Also, like there are some nice things how you can use a nest or compact columns in the new version to super performantly convert an array of objects to an array of columns, and like have optimized inserts in Postgres and also like use as DSL. Additionally, like I used to use it for form libraries, generating open API, like decoding and encoding URL or local storage, like quite many use cases. And it's what was already used, and I already have ideas how it can be used even more in the future. And for example, like it's quite doable to generate optimized deep equal clone, like create the default values function comparison. When you have a schema definition runtime, you can do many cool things with this. Like it's PPX, but in runtime. And in runtime, it's more powerful because you can modify it or augment with your custom runtime logic. Also, it's possible to do performance optimization since Suri uses just-in-time compilation. It might do quite cool things like optimize JSON string serialization, built-in support for binary formats like proto, CAPNP, etc. So this is quite cool. And for those who don't really know the syntax, it's like the concept and the main idea why it came to life like 4 years ago or already more. I was writing an HTTP server on Fastify, and I was struggling that I have a type definition in one place, I have a decoder in another place, I have an encoder in another place, and then I need to write a JSON schema. And these are like 4 different parts which you need to only like write tests to verify that there is no single source of truth. And with ReScript schema, and especially with ReScript schema PPX, and I know there are going to be more talks about PPX later, so it will be interesting the direction it moves. For me personally, as a user, I find PPX is quite nice in terms of convenience, but yeah, I know it has quite many problems. And yeah, it allows you to have a single source of truth, and then, for example, you define a schema, you define a type, and this is especially powerful with unions because you can define a type and then write by hand a schema which relies on this type, and it will be type safe. But with unions, it's tricky because it requires you not to forget to add all cases, which sometimes you can potentially miss. And this PPX solves this problem. So define only type. The type is a source of truth, and you add this PPX add schema attribute, and it generates you schema. And you can, for example, use the schema. In the latest versions of Suri, schema is a superset of JSON schema, so it's quite powerful. You can use many existing tools which already built for JSON schema to do some traversing of it. For example, you can log and see like what the nature of the type. You can use the schema for parsing. Like it also gives you very nice messages, and also what's cool is that it has a built-in encoding in place. For example, you can have this like pass the on variable and encode it to, for example, either JSON schema, JSON string, JSON just unknown. So this is features from the version Suri 11, which I've been working for the last year, and all the people wait fixes, which it includes. So yeah, where it went wrong. Let's continue with the main part of this presentation. I think the main reason is my futuristic vision, because I want it, and I still want to create the best schema library. And yeah, I think this is bad from one point that it creates quite a lot of burden on me, but it also drives and motivates me because I see that this is possible. And a year ago, we had quite a different situation where AI wasn't this in place. And I had a vision that to build the best library, you kind of have 5, sometimes more different pillars, like TX, I think it's one of the most important. Performance and bundle size are not that very important. I think ecosystem or community is equally important as development experience. And then you have like performance and size, which are also good. And then having simple code so that you can sacrifice it if you maximize other aspects. So my goal was to, like, this reddish one is like other libraries, and the white one is, for example, Suri. So I wanted to move all these 4 pillars to the maximum and like to do much better than all the other libraries combined, and sacrifice code simplicity for its sake. And this is actually backfired, because at some point it increased the mental burden to do a simple change. Like other people, it was quite difficult for them to reason about what's going on whatsoever. Also, like, for example, Gabriel asked me, like, how does this work? And I just said magic. But it's not magic. It's just quite a lot of code, which was quite messy at the time. Yeah, and now AI came, and you can't even develop with AI because the code is a little bit like, yeah, I would say weird. Yeah, and also you have architecture which don't support new features and hinders the development. So this was main problems, I think. And yeah, and I wanted to develop it more. And I started a PR, and I try to, yeah, I usually try to keep changes small, so iterate like one by one. But yeah, I tried, and yeah, because of the like code complications and like everything was coupled, and yeah, so I ended up with a huge PR working on it for 8 months, I think, already. And yeah, it's still in development. And everybody who creates a new issue, I say, like, it's going to be fixed in this PR, but I still don't know when it's going to be merged. I believe next month, but I might be too optimistic. So yeah, the current state of things, I have this huge branch. It's an active development, but what's good is that I think it's relatively close, and the code got much simpler, and yeah, it's simpler, less like weird optimization heuristics there. And yeah, I managed to describe it in a formal language. So AI starts helping me to work on this. And this played quite well. And recently, I went, I think, from 60 failing tests remaining to 22, this presentation says, but I think at the moment of this talk, it's already 17 failing tests. So it's quite decent. And yeah, architecture is already quite stable. So all these remaining failing tests, they won't affect the library internals much. So this is just like updating and fixing a few places, but not the whole architecture. Also, the latest version, I got a stable schema API. I mean, like when you create a schema, it has a bunch of fields. Like, for example, you create an int32 schema. It will look like a integer JSON schema, like under the hood. So if you log the object, it will have this type, all the stuff. So I made this schema API mirror how the JSON schema looks under the hood with some superset for additional fields which are needed to generate decoders and encoders. So yeah, this makes a library more stable and easier and more reliable to build on top of it. The schema creation API, like for example, when you call as that something, is not that stable, but I think it's getting much closer to the vision I have. And what's important is that it supports standard schema. So for example, if the way like a parser throw changes in the future, at least you can reliably use the standard schema approach, which is nice. And yeah, I finally managed to make AI understand the code base, which I think a good step forward for developing internals by myself and also bringing in other people. Yeah, and also PPX, it exists. I don't know the future of PPX in the ReScript ecosystem, but it's not affected. So if you want to improve something in PPX, feel free to suggest your pull requests, I'll gladly review them and accept. And yes, I'm going to wrap up with the talk, and maybe you'll have some questions, or I don't know how it will go. So what's next? Yeah, I think it's what's important. Like, let me know if you use Suri and if you want to contribute. Like, if you don't know what to do or how you can help, just write me and we can figure it out. Also, this big branch, let's treat it as mainstream. How is it called? Like, so the latest, I'd say the latest version. And also, like, feel free to suggest pull requests, or like, there are 17 failing tests. If you want to help with fixing tests, you can do this, and I'll also gladly accept here. So there are no major changes planned in this version. So also don't feel afraid to contribute into the core logic as well. So yeah, and from my side, I'll also work toward further simplifying and stabilizing internals so it doesn't end up rewriting the whole library every year or something like this. Also, I'll write a detailed contribution guide or even improve the agents MD file. I think nowadays it's even more important. Instead of opening contributing MD, you'll just read the skills and agents file. So yeah, I think being able to describe architecture and code structure in formal language is very important for development by AI and other people. And I think I got decent improvements there. And yeah, I hope it will end up useful for community members who will decide to contribute. Yeah, and after I finish this branch, I think probably will take months, hopefully less. I'll plan to write a series of articles explaining how internals work, like all parts, depending on this, like JIT compilation framework, schema creation, JSON schema creation, like how the operations are cached. So for example, if you call parser throw, it uses just-in-time compilation to create this parser operation once, and then it caches it, and the next calls it will reuse it from cache, like how these things work. Like, there are quite many interesting parts and optimizations in the ReScript schema or Suri internals. So I think I'll need to write an article because sometimes just looking at them without a context, they will just look weird. Yeah, so let's keep in touch. Yeah.
Thank you, Dimitri. So first of all, a round of applause for this great talk.
Yeah, I don't hear.
So maybe there is already, I can already imagine there is a bunch of questions. So if you have a question, please raise your hand so I can give you the microphone.
Can you just go a little bit into detail about what standard schema is in case anyone's not familiar with that?
Let me try to. So standard schema is kind of a standard which was created maybe a year ago by creators of Zod, Valibot, and Archetype. And the idea is that a library can support the standard schema by implementing this interface. So every schema which implements this interface has this tilde standard field on a schema object, and it implements some functions like validate, parse, and I think the latest version also implements the JSON schema. Like so what it means, like let me find some example. So there is like a bunch of libraries which support this standard schema, like this schema libraries. And there is also a bunch of libraries like trpc, tanstack form, tanstack router, which can work with schema supporting like this standard. So like this means that all this library also supports ReScript schema or Suri, because you create a schema, pass it there, and it will work out of the box. So these libraries, let me try to explain in other words. Let me find. I'm going to increase this screen size in a second. I'll open this one. So instead of library knowing that, for example, I need to call this sparser to be able to parse the value and all this stuff, like for every library, this is different. They can use this standard schema spec. So we just pass any schema to the library and it will work out of the box. Yeah. Sorry, this is a little bit confusing explanation, but I hope it makes sense. Yeah, I'll share this link somewhere with you, or you can just Google standard schema. Yeah,
Thank you.
This is quite cool.
Maybe one or two more questions, if there's any. All right. Then thank you, Dimitri. Really nice having you on stream. Yeah, and enjoy the show later on. Thank you.
Yeah, I'll join you on YouTube stream. Have a good retreat, everyone. Bye.
Did you mirror the screen?
Yeah, sure.
We're currently experiencing some technical issues. Bear with us a second.
Do you like... Mirror, yeah. Try that one then, optimize for...
There's the Ukraine one.
Guess maybe... Works? Are we ready? Okay. I'm going to talk a bit about ResX, which is a framework I've been building on for a couple of years now. Initially, mostly to, as always, scratch my own itch. I build websites occasionally. Normal websites are supposed to show up in search engines and just be HTML, essentially. And yeah, I've said that it's PHP meets JSX and type safety. It's not really PHP, but still, it's a pretty good analogy of the what I've been going for. I've done a lot of PHP back in the absolute beginning of my career, and there are lots of horrors of PHP, but one really nice thing is it's all very much boxed into one single place. It's all collocated. So I started working on ResX to see if I could make building websites faster and nicer and more stable, and kind of in a way that I'm used to building apps, but I don't want all of the client-side fluff, essentially. So yeah, I'll just briefly go through. Before I do that, I'll show I vibe coded a small retreat website with this last night. AI has it's supposed to have looked at the text we had in the forum, and I kind of gave it the schedule as a CSV file, and I gave it the forum post. But it's made up as 5 days and a few other things, so don't worry about the texts. But this is very much just a regular website. It has sponsors, talks. It even has a small admin section where you can go in and you can edit talks, and you can edit sponsors, add new stuff, and so on. So what I'm going to be doing today is I'm going to go through ResX as a framework and also look at this website, exactly how it looks. And it's very small, so it's not going to take long, I hope. So yeah, for ResX, it's a thin framework, and it's almost all server-side. And when I say it's thin, it means that it's really not that much. It's trying to delegate almost everything to just being regular, responses and HTTP and all of those things. It has a couple of built-in useful helpers for example, for producing good cache headers and that type of thing. But it's all very much not built into a framework in the sense that Next.js has, for example, where you configure stuff and then something magically appears with headers somewhere. You're always in control of setting those headers, where they are set, exactly how they look. You can always access them. So it's trying to move things away so that you're only dealing with the core, essentially. And really, most of what ResX itself is, other than a setup for building with Bun, is it adds JSX, which we all know, and hopefully most of us like it as well. It's a nice way to be able to componentize things, even websites, even though it's not a full app. There are still, it lends itself well to the component model. It has a thin integration for a very hooks context-like integration where you can always access the current request you're in, no matter where in the app you are at. So you can set headers and stuff, and you can access the current URL and everything as you build your website. So it has kind of strong React vibes. I'm saying it's great for SEO just because it kind of gets out of your way. It's very easy to just emit whatever you want into the HTML, add things to head, orchestrate all of those things. It also has a full asset pipeline powered by Vite, so it's easy to add images or CSS, fonts, whatever you want to have transformed, you have full control over that. You get a nice asset map where you can just include from the ReScript side assets linked in, which is nice because you get the sub effect that with reanalyze you can get dead asset analysis in the app. So it's really easy for you to see when you have an asset that you're never referencing anywhere. Yeah, and I've started focusing on security aspects a bit as well, because that's usually something that's easy to forget. So it has CSRF integration. It enforces a couple of security things wherever it can. I'm planning on working on CSP integration and that type of thing. And one thing that I've really found enjoyable with this is, since it's all server side, unless you explicitly move things to, there's a very clear boundary between server and client. You really can't leak stuff unless you explicitly put it in the HTML, because there's nothing going to the browser outside of the HTML you produce. So that's been quite nice, especially in the age of AI, where slop will happen, and you also don't really need to worry about that because that slop will be on your server, so it's not going to be shipped in 4 megabytes to the client, which is quite nice. And also, AI works surprisingly well with this. I am guessing it is just because it's mostly components and HTML. It's very bare bones and basic. So if we look at this specific app, we have an entry point. Whoa, did I get a new color theme in my editor from? Nice. A very simple entry point. I treat routing just as we treat routing in regular ReScript. Switch on path names and then switch on a list of, let's see here. Here, for instance, as we render, you can switch on just a list of the path we're on. Render a sitemap, we render robots.txt, and then if none of that matches, we render actual HTML and just have our routing set up like this. There's also some nice things here where you can edit the response before it's actually sent to the browser. So you can make sure, for instance, that if we are authenticated, we never ever have any caching on. If we aren't, and we are doing a GET request and nobody else has set a cache control header, then we set our own for 15 minutes and so on. So it gives you a few hooks to kind of hook into different things. This is quite nice. So if we jump into the sitemap, oh, is this another, do it the old-fashioned way. This is an XML file, so we can set a doc header for XML instead of HTML. Here's what I talked about with the request scoped context. So you get a handler.useContext that you can call anywhere. It's going to draw its headers, request controller, and URL from the current request, regardless of where you are. It all runs in an async local storage thing. So you can set the current request doc header, you can set your headers just here in line, and then you can use JSX to just produce XML for the sitemap itself. Similarly for robots.txt, you can also you can unset the doc header, set something else for the content type, and just emit a string. It all kind of works. And if we go into for example, the schedule, it's all just a JSX component. We have a small helper, page head. What this will do is it will render a bunch of tags into head, essentially. So you can, anywhere in your app, regardless of how far down you are in actually rendering the app, the HTML, even if you're at the very end of the HTML or end of body or whatever, you can always stuff things back into head. So it'll orchestrate that for you, which means that you could theoretically have a integration where you only load a client JavaScript library if it's actually been accessed, and you can track that through the context and emit it into head before you send a response if it's actually been used anywhere. So you can do a bunch of those things. But yeah, it's mostly just JSX and components. You can jump into the schedule timeline, where it's, yeah, here's another thing. So we have JSX components. We have support for async await, so you can stuff that in anywhere. You can co-locate your data fetching to wherever you are. I'm also using a library, another library I built called pg-typed ReScript, or rather I forked pg-type, which is a great library for generating TypeScript types from raw SQL queries. And this is an integration to the ReScript side of that. So I don't think I don't get hovers in this presentation, but this thing will be fed into a generator that will analyze the query and give me types for the response and all of the variables going into the query. And then it'll, this integration point will feed that back so I don't have to annotate anything. I can just access it directly in here. So I can take my PG client and I can run my queries. And then I can just produce JSX, just like everywhere else, essentially. And it's, of course, extremely overkill to have an actual database for this website. It's like 4 pages and just a little bit of data. But just to show like the integration points. And what I found is this is a pretty nice way of working when your ambition isn't to build the next big, complicated web app. You're only building a website. It needs to be really fast. It needs to have great SEO. You need to have full control over CDN caching and all of those things. This just makes it very easy to tailor what you're doing to your own kind of needs. So like I could go through the other pages as well, but it'd be pretty boring because it all looks pretty much the same. One final thing we can look at is that ResX has a first-class integration with HTMX. Do anyone know HTMX? So it's a it's a small like client-side framework that gives you tools to, instead of rendering everything client-side, help you fetch new HTML from the server and add it, like switch it out in your app. And that's been also quite nice. It lends itself really well to this model as well. So there's a first-class integration for this inside of ResX. See if I can find a good example. So here's an example of not necessarily the HTMX integration, but the form action integration. You can define a local form action or a form action on an URL. You'll have to give this a security policy, otherwise it won't run, and the security policy gets access to the current request and the context you've set up for that request, and then you kind of make it tell you to either proceed or not proceed. And then you get a handler, and here you can just do whatever you want. This is a form action, so you produce a regular like HTTP response. This turns out to be a redirect, but otherwise you typically have actions like adding stuff, or you'd call the database, and then you'd return maybe new HTML that's swapped into the current website and so on. Yeah, so it's like it's really not that much more than this. I have a couple of, just to show you some breadth, I have here's another website that's, sorry for the Swedish, it's another website built in ResX for another kind of tool we have. So it's all very like standard. And then yet another website. This is something I've built recently. It's a website for keeping track of Swedish NHL stars, hockey. So this kind of keeps track of, let's go to this view instead. Here's an example for the idea is that you look at this website every morning when you wake up, since everything's played overnight in Sweden. You can see who scored last night, where are them in points leagues and goal leagues and so on, and you can kind of go through and find all different information that you want. And here's a good example of HTMX. So let's see here. When I click this, it just swaps in the entire new HTML of this, this view. Still updates the URL and so on. Yeah, I think that's pretty much it. One small last thing I have is I will just publish this repo, And I also like added, just for fun, I added a prompt log of all the prompts I did to create the website. And it uses a pattern I've used that's worked quite well. I have Claude do a TypeScript React Tailwind SPA just because it's so fast at doing that. It creates a design. You don't have to care anything about anything other than it looks well. And then you have Codex take that and actually implement it into ResX. And that works surprisingly well. Everyone does what they're good at, right? So, yeah, here you can see the initial design prompt I gave it just for the conference website. I pasted the forum post. I gave it the CSV of the schedule and so on. And yeah. Yeah, any questions?
First of all, thank you, Gabriel.
Oh, thank you.
A round of applause, please. All right, up for the questions.
Thanks a lot, Gabriel, for the talk, and obviously for ResX, for the framework. I've had the chance to try it on a small hobby project, and I was really amazed by how easy it was to set up something. It was very easy for AI to work with it, and I was able to come up with a finished product in a few hours thanks to AI. And I guess that's because, as you said, AI is pretty good at understanding the concepts behind ResX. So now I think it's in a pretty impressive state. Do you have any, I don't know, marketing strategy to advertise about it? Like, I don't know, on Hacker News or something? Because like, I think it's a killer app for ReScript. Like the whole DX and productivity you get from this framework is pretty impressive. So what's next?
Thank you. So I think what I want to do next, if we start like technically, is I want to focus on adding, skills is one thing. So like targeted skills for AI, but also adding I find like having a sample repository with all of the best practices in it helps a lot, that you can just clone locally into your project. In terms of marketing, I don't know. Probably not going to do much. I use it for a bunch of things. I built everything from client websites into my own stuff. It's really like a pretty small thing. I encourage you all to try it out if you have some sort of website you need to build, just because it's refreshing to. It's like a really simple and dumb React app, right? Like it doesn't have much other than components and layouting. And it's kind of refreshing too, because that's mostly what a website is, right? You still have components, you still have the same concepts and so on. Yeah, so and then deepen, there's a couple of interesting things you could do. I think I want to do a proper router for it, like, because I found in larger projects that things get a bit messy when I do everything by hand. So something like that, but yeah. For the router, I think I maybe take the ReScript relay router thing and just adapt it to something that doesn't require.
Okay, so
relay
based on JSON, I guess, for the router.
Yeah, and then I also want to look in more into the kind of islands architecture thing. So like we'll hear talk soon about another ReScript native front-end framework, but I would like to see if I can make it really easy to just pop in a client-side framework to render where it makes sense in your website. So, and also make sure that integration is so both it's easy to include JavaScript, of course, and have it render client-side, but also it's easy to incorporate a server-side rendered initial version of that island into the server-side rendered thing already in ResX.
Any more questions from this room, at least? I have a few questions in the chat, or at least one. So Atzeke Profit asks, is this mostly for static content? Is there handling of form data being sent from client, for example? Yeah, so like it's, like forms, definitely something you use a lot with ResX. There's
there are a few like small helpers around extracting the information you expect from form data, but otherwise it's all just regular HTML. Like you have a form, you put your fields in the HTML, you put your hidden inputs and whatever you need. You have a form action, you extract the data, work with your database, return the new information back. So it's, yeah, definitely like it's, so where this does not excel is when you have a very granular and interactive application where doing something probably updates a bunch of different things inside of the UI. Like you're gonna hit a wall pretty quickly with HTMX, where it's good at replacing parts of the UI. It's good for that type of interactivity. But I mean, if you're doing a full-blown app, this like probably isn't the right fit. But turns out like most things, like most websites aren't that. Like most websites are just static content with just a little bit of interactivity here and there, some forms, and this makes it really easy to make these. And yeah, and again, like for me, for the things I've done, the big thing that's been good is that you're so close to there are no abstractions in the way of you. You're so close to the core all the time. So doing things is just really easy. Like integrating a CMS is super easy. Like you just fetch the data you need. You're all server-side. You don't have to worry anything about, like you have to worry about access, of course, to your app, but just fetching things server-side. If you need a cache to the CMS, you have that server-side. And so on. Like I did, if you want to add turnstile from Cloudflare for spam protection, that's just integrated. AI is great at integrating those things as well. Like it's all very straightforward, which is what I think has been working really well with it.
All right. Thank you. Then another round of applause, please.
Thank you.
All right, so we're getting ready for the next speaker. This will take some time, so I will just stand here being a talking head. So just wanted to take a minute. First of all, do we know who the next speaker is? Yeah, Jaap is going to be the next one. So just set up your computer, put in the HDMI. We'll make sure that the stream setup is working. But while we're doing this, I'm also trying to stay in the screen here. Just wanted to take a minute to also thank our sponsors, especially Chain Street as our main sponsor. Without them, it would be very hard to organize this kind of events because, as you can imagine, there's a lot of people coming from all over the world. We have Moon here from South Korea. We have Josh here from Boston, coming all overseas. So also not very easy travels. So I doubly appreciate all the effort that everyone is doing in the community to come here to just, do some hacking, which is kind of amazing. Also, our other sponsors like CCA, a longtime sponsor, has been trusting us forever, and they are also like main contributors to the platform. So also very grateful for that. And of course, also the company I'm currently working for, Catrix, for providing the venue and also like being a good host here. Yeah. It seems like we're already getting ready here. So, yeah, it seems to work. Just the most important part. Let's pray it works. And then we're gonna check your sound. Oops. Yes. Here we go. Alrighty.
Works?
Stage is all yours.
Great. Yeah, so I want to talk a little bit about an experiment I've been working on, which is like rewriting the compiler in Rust. And then I also have like I had another idea. I think I worked in parallel, seeing how to do like comp time evaluation in ReScript to not have PPXs anymore. I think it's a pretty interesting direction. So I also want to show a little bit of that. Yeah, and that's mostly it. So mostly just demos, and I want to talk a bit about the why and that kind of stuff. So yeah, so let's start with ReScript 12. So at Tela we've been now fully on ReScript 12, and yeah, I've used ReScript for quite a while. And it always feels like there's a few rough edges here and there. And I think with 12, we're really in a super nice state. So yeah, really, I think it's a really big milestone. And also, the thing I worked on, Rewatch, which existed outside of ReScript for a while, really nice that we could upstream that. And I think outside of like the performance, improvements that we managed to make with the new build system, and of course adding mono repos, I think it's also like an entry point of a lot of new features that we can build on top of it. And I think some of these things are already in progress, so that's super cool. But let's talk a bit about what actually makes ReScript like interesting. And I think it's interesting to think about this because we're still a very like small community, and like we all got interested in ReScript for some reason. And I think for everyone it's slightly different. And for me personally, like why I really got into ReScript, I knew about ReasonML, but the reason I really started using it was because I used GraphQL on the back end. And back then it was like the only real solution to get types, to get a completely type safe, have all the GraphQL types of a query inside of a typed language. There were some things for TypeScript, but back then the ReScript implementation with the PPX was like really good, and that really got me into it. And instead of like just playing around with it, like really start adopting ReScript in an app. And I think it's interesting to think about, okay, what is it like now in 2026? And I think in extension of that, what's the future of like programming languages in general? I think at first, when the LLMs started using LLMs, I was like, okay, the ReScript is not in a great position because we don't have that much code in public, and languages like TypeScript or like that are used a lot or Python are like, the LLM is so much better in generating code. And I think recently that has changed, where syntax is not really a barrier for LLMs anymore. It can write niche languages like SIG or ReScript like really well. It doesn't really matter anymore. So I think that changed our like position as ReScript in a very big way. But the question is, where will it go next? Because now it can write ReScript really well. It doesn't really matter anymore. But maybe at some point it will just write assembly code directly or something. So I wonder what will happen, but I think for now we are in a very good position because of the type safety that we have, and like what I experienced, like LLMs just work really well in a sound type system. So it's really good at Rust. It's really good at ReScript. Like if there's a type error, it can really easily recover and stuff. And you don't have that many bugs in the produced code. Okay, so that was in general. So I basically, you have these LLMs that can produce a lot of code and do this big project. So I kind of like, at some point was in Cloud Code, and I was like, can you rewrite the compiler in Rust? And it started doing it. I think in general, I think it's interesting to think about, okay, with LLMs, like what is a really good project for LLMs to autonomously work on? And like there's a few projects also from the labs where they created like a C compiler from scratch, or I think Moonbit, or Moon, the other project of Bob. I think they also did like write a compiler, a C compiler in their language. But I think one of the criteria, you need a few criteria for the LLMs to like really autonomously build something. And writing a new version of a compiler is like a very good example where you really have a clear success criteria. Like, you know, does this source code compile, yes or no? Like, it's very objective, you can test it. But that alone is not great because, you know, it's very complex. The compiler is like a very complex program and you don't one-shot it. But the nice thing about it is that you have a lot of internal representations. So for instance, for the parser, you have the parse tree, and you can very easily improve. Like, so you might have like a source code, and then you produce like an AST, and okay, AST is not correct, and you can see, okay, what's different from the AST that the OCaml compiler produces and what the Rust compiler produced. And so it's really, like the LLM can really iterate very well on it. Like it can do a lot of things to diagnose and to see what's the problem it needs to solve. So it can read both the references, so it can look at, okay, the source that it created, and then it can look at the original reference source. It can look at the outputs and see the difference, but it can also just add logging everywhere. So it can like see what's happening internal in the program. And this is like, there was this auto research project of André Carpati that is like very similar. Like he applied it mainly for like a building language model and iterating on the quality of the model. And you have similar success criteria there. But it's like aside from like the use, it's a really good project to do with an LLM. And so I burned a lot of tokens because it's like, yeah, you just need to let it run for a long time. So I made a rough calculation, and I'm now at like 15K in tokens. Of course, I didn't pay for it, all of it, because the subscriptions are really subsidized, and I maxed out. So it's not completely done yet. It is. It's doing everything, like going from source code to the generated JS code. But the generated code is not 100% in parity yet. And right now it's about 200K lines of code. And I think the OCaml source is a bit smaller. It's like 150K lines of code. But yeah, but like Rust is a bit more, need a bit more code to do the same thing. Yeah, so question is, why would we want to build a compiler in Rust? And like, since we've been working on the build system, it only handles the build system, and the compiler is still this bsc.exe that we call. And we don't really have a way to optimize it a lot. So yeah, I think there's a lot of benefits for having a single program that's compiling and building. And there's currently how it compiles, it's pretty inefficient because we have multiple steps. So we parse, then we generate an AST, then we call the program again to compile, and then it creates compile assets. And then when we compile a different file that depends on, has a dependency, it looks up the compile assets for the interface on disk. And yeah, it's like going to the disk to read something is just really expensive. So like a lot of the modern compilers that are really fast, they try to do as much as possible in memory. And in order to do that, you need to have concurrency and parallelism, because like right now, the compiler is just compiling one file in a single process, and then it quits emits compile assets. And so you don't really have to think about parallelism. But yeah, so if you want to do it in a single, in memory, you kind of have to do handle this parallelism. Yeah. And so if we look at where we are, like we're not really slow, even if a lot of stuff is not that efficient yet. So we're like, at least it depends on, like, of course, like the code base. But when I run like ReScript on the Tela repo, which is like a pretty large repo, we get about like 15K lines of code. If you compare that with some other languages, it's a wide spectrum, but TypeScript is in the same ballpark. And then with the new implementation, where they have the Go-based compiler, they're actually much faster. But this is, I think it varies a lot, like because if you do very complex stuff in the type system, it can slow down a lot. So this, I think it's on the VS Code base, and I think they made sure it compiles fast, and they don't do a lot of stuff that makes the compile slow. I think one of the problems with TypeScript is that you can make the compiler, the compile times really slow if you do certain things in the type system. And I think it would be great to be at least as fast as TSGo in compilation. And if you see, like some of the native languages, they also need to do a bit more, because they need to create like binary code, which is a bit harder than just generating JavaScript. And if you look at, like, for instance, Tiny, like a C compiler, maybe that's also a bit simpler than the type system we have to compile it, but it's like really, really fast. So I think there's a lot of opportunity to be a very fast compiler. And yeah, so you can go basically two directions. You can go, okay, let's write everything in OCaml. But there are some downsides to that, because in OCaml, parallelism, they added it in OCaml 5, but it's a bit immature. And the performance is not bad, but it's also, there's a ceiling. There's stuff that you can do in Rust to make it fast are just way more. Like, you don't have a garbage collector. You can, you can very much be in control of the memory. Another thing of OCaml is, like, the ecosystem is not that great, and that's also something we run into when we built Rewatch. That yeah, it's with Rust you have so many like good packages to do, like concurrency and that kind of, and like it's such a great ecosystem. So that's an upside, and it's not necessary. It is like maybe a path that's a bit easier, because the compiler is already right now in OCaml. But it's completely designed around this execution model of out of process and a lot of global state. So it's not very trivial to build it in OCaml as well. And I think before LLMs, like, rewriting in Rust would be pretty insane, because it's such a huge project if you would do it manually. But I think with LLMs, it's like the calculus changes quite a lot, especially because this is a project that's so fit to do with LLMs. And yeah, ReScript was bootstrapped off of OCaml, and we kind of went in our own direction with ReScript. And I think it's a good time to kind of like graduate from OCaml and really own our own compiler. We already do, but it's still very much the OCaml type checker that is doing all the work. Yeah, and I also think like Rust is very similar to OCaml. It's very much the same and just has more lower level capabilities. Okay, and so why does it matter? Why does a compiler need to be fast? And I think like with agentic engineering, speed is just really important because every compile is slowing down the agent. So if you can make it as fast as possible, I think that's very useful and just lowers the feedback loop. And LLMs are not that fast yet, currently, but they will be much faster, and then it's even more important to be fast. And I think one of the things as well, when you work with agents, like they depend a lot on, like you want to make sure the CI is green, and making that really fast, I think, is becoming more and more important. So for instance, ReScript on our CI with Tela, it's like a 250K lines of code base. It's taking 15 seconds right now, but it would be nice if you can reduce that by a lot. So I think like we have to think about, okay, what will be the driver of the adoption for ReScript. And we also have to look at, okay, what do we do better than TypeScript? And I think TypeScript, the type system, is less type safe. So if you're not writing the code anymore, I think we have an advantage there. And with TypeScript, like I said before, if you make the wrong choices in types, it can slow down the compiler a lot. And the way the ReScript type system works, that's not really an issue for us. And I think another reason, like I think a lot of people didn't really adopt ReScript because you need to learn it, and the whole team needs to learn a new language. And that also is changing right now. Like, if you use agents, you don't write the code yourself anymore. You don't have to learn actually the language. You need to read it, but like it's much easier to adopt in general. So, I forgot about the demo. I actually wanted to do it a bit earlier. But so how it works, like. So you have a few different stages in the compiler. You have the parse tree, you have the type tree, you have the lambda representation, and then there's some optimization passes on the lambda, and that's like the last stop to generate the JavaScript. And so for each stage, I basically run it on a very large corpus of code and made sure that it produced the same internal representation. So all the stages are 100% right now, except for the codegen. It's not 100% there yet. LLM is still running on that, but it's close. And of course, you can make it correct, but then making it fast is another thing. So the type checker is 100% correct, at least on the corpus of code I checked it on. But it's not so. It does still make some suboptimal performance decisions. So that's another step to, and you can also do it with LLMs, like measure how fast it is, and then it can make some optimizations. So for instance, the parser is already like really, really fast. The type checker is faster than OCaml, but I think there's a lot of opportunity to make it even way faster than that. And a big difference of this, like it being in Rust, that I can completely plug it into Rewatch. And I also removed the compiler assets that we emit on the file system. So it just goes straight from a ReScript file to a JS file, and it doesn't produce any assets on disk. So I built this playground. So this is running the compiler in Wasm. So just because everything is in Rust, you can really easily compile it to Wasm, and then you can kind of inspect the trees. So this is the parse tree. Then you get the types. You can inspect the types. And then you can see, okay, what lambda does it create? And in the end, okay, this is the JavaScript that it's producing. Yeah. There's not much to show because it's kind of like the same compiler, but then in Rust. So, but I think the other experiments is a bit more new and in general like something I think we have to solve. So I think one of the big problems with ReScript is that we have meta programming, but you have to do it with PPXs. And you need it for a lot of stuff. Like I try to make a list of some use cases where people generally use PPXs. Like if you want to serialize, very basic, almost everyone is using a PPX for that. Like you want to serialize to JSON. Or for GraphQL or like type deriving. I think like embed lang is like a PPX that is very useful. Form generation, CSS and JS. So there's quite a lot of use cases that you cannot really solve inside of the language. But PPX are really a problem. You can't really make the compiler fast, like in this new model where you do everything in memory. But then for a PPX, you have to run a PPX for every file. So it will never be really fast. But maybe that's not even the main problem, because you're kind of like stuck on like having a binary that reads a specific AST. And so if you make any changes to the internal representation, like all the PPX will break. So I think that's not ideal. And I think another one that's really bad right now about PPXs is that making a PPX, you have to ship binaries for every platform and make a package out of it. And if you just have a small use case where you want to use meta programming, it's just too much to do. But I think we had a lot of thoughts about how we could improve this. And in general, like in most languages, it's just not ideal to do this. A lot of languages have a similar thing like PPXs. And I think, for instance, in Lisp, you can do macros in a very nice way. But once you have like a typed language, that's not like the homoiconic, like the source is not the same as the data structures. It's just not great. But there's like one language that I think does a really good job with this, and this is Zig, and they have like a concept of comp time, which is basically you can kind of like say to the compiler, okay, can you evaluate this during compile time, and you just write the code like you would write normal code. I think this it's really nice. You don't have to worry about transforming an AST. That's very complex. So I tried to create a prototype, like Moon did another prototype, and it's actually we ended up at a very similar end result. So it's really actually quite interesting. Like, I think the main thing we have to think about, okay, how does the syntax look like? What do we include in comp time and what don't we include? But yeah, so this is, for instance, so it's a bit more powerful than a PPX that just works on the parse representation without types. With this actually works in a type system. So, for instance, if you want to build like an encoder, a JSON encoder, you can annotate like a function with comp time. And then for this value that gets passed into this function, you can get the type info. And the type info is like all the different types that we have in ReScript. So it can be like a string, an int, a bool, a record. And then for each of these types, you can say, okay, this is a string, so encode it as a string. And then like a record is a bit more complicated, but you have the fields. You can make yeah, this is basically the pretty simple code to do this. And the nice thing is if you have this encode function, it will work everywhere. You don't have to annotate anything. You just pass in a type and it will encode it. Variant, very similar, where you get the constructors in the type. You iterate over the constructors. And then you look for, does this value have this tag? And then you encode it. Yeah, so what happens, so you can basically define this record, or this value, and you can encode this value. And we'll just produce this code. Wait, we have the code, yeah. So it will create a specialize for each type, create a new function. So you get a function for the status, which is variant. And you get a function for the address. And it would produce this pretty like clean code. I'm not sure how we are in time, but like the decoder is very similar. You can, in this case, you get JSON, so that's not typed. So you always have like a first parameter where you can also pass in a type, and this is the type that you want to decode it into. And then you can look at, okay, what's the, you can get the type info of this type, and then you can do the thing basically in reverse. You can pattern match the JSON. And then if the requested type is a string, you can make it a string. Yeah, so, well, it's pretty, works pretty well. And then so this is basically working with values and producing like this encoder stuff. Another thing is, for instance, if we have this record, sometimes you want to have like all the fields in a variant, and this is also pretty easy to do. In this case, we construct a type. So you pass in a type, which is the user, a comp time function called keys, and then you introspect the type again. And for this one, it needs to be a record. So if it's not a record, it will give a compiler error. But if it's a record, we just iterate over the fields, and then we create yeah. So we have some comp time functions, and I prepended it with an @ sign to make it clear that it's not a normal function. And so you can build a type, and in this case, you build like a variant, and it will emit like. So if you do this.
Is it get or is it the type here at comp time later?
Yeah, yeah. Okay, so this is a good catch. Like it's let, but it should be type. So it should be like, and I didn't even copy this in the playground, but maybe we can pass it in the playground. Wait. To make sure it actually works. Yeah, so this will be a type. But like the syntax should be type. But it was a bit easier to do it like this in the prototype. Yeah. So you can produce types, you can produce like functions. Another thing is like partial, which actually something we like in the telecode base, we have like HTTP routes where we want to patch objects. And so basically we have to implement two versions of an object. One is like with all optional records and one is without. And you can very easily make like a comp time function where we say, okay, I want this record to be like be optional for every field. So you can build a record, iterate over the fields, and then make them all optional. And so the partial user will be a type that's that. So that's pretty cool. So until here, it all works by just evaluation in the compiler, but we don't evaluate to JavaScript. We evaluate inside of the compiler. We look at the control flow and we evaluate it. And so for simple stuff, that works fine. And you can get pretty far with it, I think. But for some things, like for instance, we want to uppercase something. You can also evaluate it, but like and there's also the question like how far should we go? But I made like a comp time annotation where basically this runs it in a JavaScript runtime. So if you call uppercase this, it will produce just this value in the source code. So like just to show, the produced output will be just an uppercase value. And you can use this in combination with the other stuff as well. Yeah, and yeah, so this is all the types. And it's not 100% complete yet, but once you have like this type info like complete, you can basically do everything. Like you can see every type in this thing. Yeah, I have some more examples, but maybe like are there some questions or?
Thank you, Jaap.
Yep.
All right, let's do a round of questions. Are there any questions here? Was quite a lot to unpack, I believe.
Yes.
Well, that's pretty amazing. Do you have any rough idea of what's remaining to make it, well, kind of matured for a replacement?
The comp time or the compiler?
I guess the comp time comes with your new compiler, right?
Yeah, so the comp time actually, I think possibly we can also build it in OCaml. I just built it on top of the REST compiler because I was working on that. But I think we can also build it on top of the
I guess
the compiler.
Moon is probably
normal
gonna
compiler.
show something in OCaml, right? Yeah, so we can compare.
Yeah.
Thanks.
And for the compiler itself, yeah, it is pretty far, but to make it like really good, I think there's quite some work left. Yeah.
All right, any more questions?
All right.
Thank you, Jaap. Then let's. We're now heading out for a break. So basically, we'll probably come back in roughly 15 to 20 minutes. We're gonna make sure that we're ready for lunch, and then for everyone watching here, we'll be back. We'll keep the stream running, and yeah, so roughly at, I don't know, 12 during lunchtime, I guess we will just continue, and then we'll see how this goes with our lunch timings. All right, then see you around in a bit. Thank you very much.
Stay
Alrighty. So we're now tuning back from our break, and we'll continue with our free talks. Moon's going to be the next speaker here. So yeah, then stage is all yours.
Thank you. Today I want to give a short introduction to the ReScript Comtime POC. Actually, in previous session, Yap already showed too many things, so it's not going to be different. Interesting is we are not discuss too much before coming to the retreat. We were preparing the POC and the user surfaces and syntax, but in the retreat we met and discussing, and we found out and surprised that almost the user surfaces and syntaxes is very similar. So, okay, I'm gonna show my POC with old OCaml compiler. I'm one of big fan of OCaml, so I feel like I'm gonna miss OCaml era. Okay. Today's goal is not to go deep into compiler internals. The goal is to explain why this might matter for ReScript users. In one sentence, the idea is metaprogramming in ReScript with explicit compile time generation and evaluation for ordinary values and types. So instead of treating metaprogramming as a separate ecosystem with complete different authoring model, the POC asks whether we can keep a surface much closer to normal ReScript. One important framing point before getting into the details. This is still highly experimental. A user interface and API are still being designed. So this is not a finished product announcement. Okay. So why existing PPX feels heavy? Like I said, as one of big fan of OCaml, I enjoy to write PPX much, but PPX is bye-bye now. The motivation starts with familiar problems. There are many tasks where we want a bit of generation, but PPX still feels too heavy. In ReScript, that heaviness is very concrete. ReScript syntax changes can leave PPX support behind. PPX authors usually have to write OCaml instead of ReScript. And the NPM distribution often means platform-specific native binaries, which makes packages larger and install more complex. So the issue is not that PPX is impossible or useless. The issue is that it is often too expensive for small and everyday generation tasks. What users actually want? The next point is, in many cases, the requested outcome is very small and very understandable. You want, such as you want an encoder, you want a decoder, you want a copy function, you want an all cases array for a variant, or you want a derived type alias. That gap is main motivation for comp time. The output users want is small, but existing path to get there is still heavy. Comp time changes the authoring model in very specific way. Instead of writing an external transform as another language, you write a generator as an ordinary ReScript helper. Then you opt into compile time behavior explicitly with % comp time, like existing syntax, like extension syntax. So % comp time. This is a little different from YAP's comp time. I'm kind of stick to existing syntax because % comp time means generating the expression without any other things. On the other hand, like at comp time would be like generating with existing expression. So there is a difference. So I kind of stick to existing syntax. So inside the boundary, you can call reflect function to inspect the chosen target type, and you return generated runtime code or generated type descriptor. So the center of gravity moves. Meta-programming no longer starts from a separate PPX ecosystem. It starts from ordinary ReScript code. At the surface level, the proposal is small. Users opt into compile time behavior with % comp time that can produce value level code like an encoder or a decoder, and it can also produce a type alias. The important mental model is the code side determines a target type. The reflect function call exposes a compact descriptor view of that type, and an ordinary ReScript helper returns generated code or generated type descriptors. So the public surface is not trying to expose compiler internal directly. It is trying to give users a small explicit model that they can actually learn. This slide is like a mental model. Like I designed the reflection model, such as descriptor space and reflected members. This is a kind of helper function. So reflect does not expose the entire compiler type system. Instead, it returns a compact descriptor spaces for the kinds of types we want to support, such as, and then there are small numbers of accessors for fields, tuple items, and constructors. So generation is driven by a reduced reflection API, not by direct public access to the compiler's full internal representation. This is showing how it works. So implementation-wise, high-level flow is type called call site first and lower the relevant expression into compile time IR and evaluate that IR inside the compiler and then turn results back into ordinary runtime AST back or generated time manifest. The important takeaway is that compile time execution lives inside the compiler. It is not an embedded runtime inside the output program. This is the second one, different from Yap's design.
No, it's the same. Like, you can do inline as well, but normally it works.
Okay. I'm gonna figure it out. Okay. The current evaluator already handles, local helpers, recursion, control flow, assertions, fail width, and a small supported set of array iteration helpers. So model is explicit, but it is still expressive enough to be useful. Okay, this is current scope. Okay. So I'm gonna show you a quick demo. But the monitor is opposite side. It's not mirroring. Okay. This is good enough. Okay. So there are some examples, such as encoder. As you can see, it's very similar to Yap's syntax surface. So open comp time, and we do have a record type definition here. And so go for the, we can make encoder for any functions you want. So user, JSON, return JSON type, JSON.t, and comp time, make JSON encoder. So make JSON encoder looks like this, and here is the reflection model works. So inside the compiler, in the comp time, reflect will return the target type, this abstract t. So this descriptor will be handed over to another function, encode by type. And encode by type here looks like this. So pattern matching all the abstract type A, and then, for example, record. and JSON object. It returns JSON object as encoder returns. Okay. And encoders and the such as all the cases. This use case is also famous. And, when we have a variant type, we have use cases like generate the array of strings with variant. So it's almost same. Compile make all cases, but it returns array color. Color is a variant. So reflect also in same reflect will return the type of variant, array key, array color, so the pattern matching variant, and then express with the helper functions like this. So it will return array of strings. Okay, that's pretty much of it. Okay, I have some more cases. If you have interest, you can I'll share it. That's it.
Alrighty, thank you very much. We'll head over to the questions. Do we have any questions here in the room?
So you decided to annotate the type. So if you scroll down, and you have so all colors, you annotate the type.
Mm-hmm. This one.
And that will be Comtime will receive that type.
Mm-hmm.
Could you also make it that it infers the type?
Yep. Sorry.
So would it be possible to infer the type?
This function. This make all cases or.
Oh right.
Right.
So the type is the input for make all cases. Right. Okay.
Yeah.
So you actually need to provide a type in that case.
Yes,
Okay.
this one.
Yeah. Okay.
Maybe if you consume the actual function that's produced or something, then you could infer it backwards.
Yeah, if you pass in the type to the function, so it's not units to something, but rather make all cases and then put in the type.
Yeah.
Then you would infer it.
Or like if you iterate it through all colors and check that they equal or match on them, and then the compiler would know what type it is.
So many questions now to infer that.
But what is the type of reflect?
What is type of
Reflect.
reflect? Is very good question. It depends on. It's like this. Unit
Yeah.
and Comtime. Descriptor.
Okay.
Yep. There would be
And it
so many
knows,
types.
and how does it know how to get the T that's just above? Does it just get whatever latest type you
Comtime IR will handle that abstract type information and then returns the all the that define the types.
So it only gets one. So you pass it one type. I think. Also, when I was working on it, I also do it the same, only one type. What do you think about passing multiple types?
Multiple types.
So what if you say, okay, I want to do something with two different types?
Oh,
Yeah, let's
Just
merge
two
variants or something like that. Yeah.
Why not just use two for that?
Yeah, but it's
Still one type, right?
yeah, maybe one type is enough to if you have if you have a two
I'll come up the idea next time.
Alrighty, then thank you so much. Yeah, also probably a special mention that Moon was traveling here for 14 hours. So very much appreciated that you came here extra. Can you press the button on the bottom?
I used to have a starter vehicle, but it's lying down on the I assume, so I'll just update that.
That'd be nice. Can you hear me now? Just generate some Drupal box.
Yeah.
Yes. Can you hear me?
Yes. All right.
All right. Let me know when can start.
Yeah.
Okay. Hello, everybody. I'm quite excited to introduce ReScript Retreat. So, what is it? It is a rewrite of Chatien design system in ReScript.
So can you move your mouse? So
Sorry. Oh yeah. Yeah. So it has the same philosophy as Chatien. It's a pixel perfect rewrite. So you can really, well, if you know the Chatien design system, you can really reuse exactly the same components. They're going to be exactly the same in ReScript. What is really cool is that I only rewrote the components. Okay. The rest of the of the Chatien ecosystem is compatible with ReScript Chatien. So that means that we can reuse, well, first Chatien CLI. No need to rewrite this because it's compatible. We can also reuse Chatien MCP server and stuff like that. So that's pretty cool. For those of you who don't know what is Chatien, it's a design system, but it's not provided as a library. It's a collection of components that you can import individually, and you basically like copy paste those components in your code base, and then you can customize it as you want. So it's pretty good because it's pretty cool because you can have a very granular use of the design system. You can, for example, just copy, I don't know, like toast or a button or whatever, and you don't have to pull the whole library into your system. And it's also very easy to make it customized to your own design for your product. There's been a lot of debates about if we should come up with a ReScript version of Chatien, because it was originally based on Radix, which is not really maintained anymore. But fortunately, I think at the end of last year, they started forking Chatien and supporting also, they rewrote all the components for base UI, which is maintained. And around the same time, I started working on, for my own company, on a design system with a product designer. And well, it all clicked. It was a very long-standing issue inside the ReScript ecosystem, and well, now is the time to have something like that inside ReScript. And yeah, it also has comprehensive documentation. I think that's pretty important for a design system because, well, it's not something that is you know, abstract. You have to easily scroll to see all the components. You have to see how they look and stuff like that. So this is what I tried to do. I can show you very quickly. So that's how the, is it better? Yeah, maybe. That's how the doc website is. You can follow a few steps to integrate ReScript CN to your own project. This is also something I would like to add to make it easier, especially for when you start from scratch. I think we should probably add it to create a ReScript app. This would make things even easier. And then you have the collection of, well, all the components. So those are that's all CN components, basically. And they're all, well, as you can see, if you know CN, like those are exactly the same components, pixel to pixel. And if you wanna use it in your project, so let's say, for example, so I just created a very like basic Vite Tailwind ReScript app with a yarn with a create ReScript app, and let's say you want to add a counter button. Okay, so wait, that's the one. Yes. So you start adding a counter, a set count, and a button, and then you're like, okay, I wanna add a button to this project. So what you would do is you would check the ReScript CN website, look for the component you would like to add. And it's very easy. You can actually either manually copy-paste the code of the component, or you can reuse CN CLI and just put it into your project. So you would do this, and boom, 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 boom. Yeah. Ta-da. And as you can see, now there is inside the UI folder, you have got a button .res. And if you come back, well, here you go. You've got this nice counter, and that well follows exactly the same. That follows exactly the same kind of design as ReScript CN. So that's how it works. And well, it took a bit of time to come up with this. I had a few challenges that I faced. Well, the most obvious one was how to bind to base UI and to rewrite all the components. I also struggled a bit with ReScript and Next.js. This is something that I think we should probably improve at some point. And yeah, dependency tracking was also an issue. So for the bindings and the rewrite, it was, well, fortunately, mostly done by AI. I used a few skills that I found in the ReScript ecosystem. It worked okay, to be honest, but I had like two main issues. So I had to write the bindings to base UI components, and so basically they are the props of the base UI's components have like some custom props, like usually just a few of them, like dozens of them, and they also inherit from well, the usual DOM props. And they have like one specific well, technique they use a lot. They use a render prop that allows you to, let's say you have a button and you want to, well, make it render as an A tag instead of a button, but still have the button look and feel. Well, you can do it with render. This is pretty cool in itself, but that was not that easy to map to ReScript. I'm not going to talk about it too much, but basically right now this is not really type safe. I'm not even sure we can actually come up with a solution that would be fully type safe. So all I did was accepting well, a React element for this prop. And the other issue, and it's kind of linked, when I had to rewrite the Chatcien components in ReScript, so the original TypeScript implementation was, I mean, heavily uses prop spreading, and they also use data attributes. So for data attributes, it's kind of okay. You can actually now come up with your own JSX DOM types and modify them, but for the heavy use of props, it's a bit more complicated. So for base UI bindings, I had to do a few round trips actually. I first started and thought that, okay, I will just write bindings for every base UI component, but there are like tons of them, so it was a lot of work. And even with AI, you still have to review it and make sure that it makes sense. So I eventually stopped doing that and started thinking that, well, it would be easy to just have all these components use the same prop type. And every time I would rewrite Chatcien components in ReScript, I would add the missing types to this common prop type. But obviously that didn't really scale well either, because, well, depending on the component value, on value change, like all those props are use different types. So that didn't work either. So at some point I had to, well, go back to the first idea. It took quite some time, but like now it's good overall. And I also added, because like that's one other thing. I think there are no tests like for end-to-end tests in Chatcien components. So I couldn't really make my rewrite pass the same test because, well, they just don't exist. So what I had to do was that I tried to I generated the TypeScript components and the ReScript components, and I compared them. I compared their DOM definition, and I compared well, screenshots basically. So that helped AI a lot. But obviously there are limits because, like, we were talking about interactive components. So given there are no tests and that you can interact with those components, it's kind of hard to make sure that it's pixel perfect in all the different states of your components. So I also had to review manually by hand a lot because otherwise, like, there would be a lot of issues. But overall, I think it's in an okay state. There are probably some leftovers, but I think it should be doable now, and it should be pretty easy to correct it. I definitely welcome PRs for that. And now let's talk about the main issue that I've hit, is that Chatcien uses prop spreading everywhere for all its components. And well, at first I was like, okay, prop spreading is not very idiomatic in ReScript, And it can be very cumbersome because basically let's talk about like very generic components. Well, most ShadCN components are very generic. You want to be able to customize pretty much everything. So that means that you want to be able to change like the specific props of the ShadCN components, but also all the DOM, like generic DOM props that exist in the base UI components that is used. So obviously, listing the 300 props of this component was out of the question. And it was not the only issue. The main issue was that in base UI, and also because of the render technique, it would use very often object spreading. And it's not like in ReScript, you can only use record spread as the first position of your record. So you basically, spread your record, and then you can add some, you can change some of the value of the original record. But in JS, you can put it in pretty much any place, any position. And so that led to a very common issue that I had, was that it would do this kind of stuff. So let's say you have a data slot prop. It would give it a default value, and then it would spread the parent props. And, oh, actually made a mistake. It's all the props, not parent props, but whatever. And if you do the same kind of stuff in ReScript with prop drilling, you would discover something that, let's say, in your ReScript component, you have an optional prop, which is data slot. And with prop drilling, you would just provide this optional prop like that. But there is actually a difference in the semantics in JS between not providing this prop and providing an undefined prop. So basically what it would do here is that, if you provide it like that and data slot is actually not provided, so it would be undefined, it would provide an undefined prop to the JS, in this case, base UI component. And if it goes through this thing, data slot would be undefined, so it would actually rewrite props, and instead of having this default value, it would just be undefined. And since pretty much all the styling of ShadCN is based on the use of data slots, it broke pretty much everything. So what I did for now is that I used prop spreading because we do allow prop spreading in ReScript, but you can't actually prop spread a part of the record and cast the rest to another type. So this part is unfortunately unsafe, and I do it with raw.js. But I think we can do better. So I started implementing a fix that is more or less ready. I think it's more a question of, are we comfortable with having this kind of stuff in ReScript? And that allows this. So let's say you have you want to write things to this component, and you know obviously the type, the prop type of this component. You can actually pattern match on the prop record. That works everywhere basically. So you could either do it if it's inside if it's a parameter of a function. It would also work with a switch, with a regular pattern match, or you could also destructurate it in a let binding. And that allows us to, well, use the same kind of technique of prop spreading in ReScript. Obviously, one of the limits is that for now we are very cautious about pattern matching, during pattern matching, creating another variables. But I guess that's something we have to to agree on. Are we okay with that or not? Anyway, I guess in such cases, you would need to create a variable anyway. So I don't think that would really change anything runtime-wise. But yeah, that's something I would really like to, well, to make progress on. It's, yeah, the PR is here. It's pretty big. It got reviewed by Cristiano. Thanks a lot, Cristiano, because it was very big. So yeah, now it's just a matter of are we okay with that or not? Then next to the few other issues that I've hit, well, one of them is using Next.js with ReScript. Overall, I was a bit disappointed by the experience because it doesn't play well with the app router in Next.js, because you have to have, well, the way the Next expects your file system to be makes it not a great fit for ReScript, because it expects a file that have the same name, like index, like well, parameter files and stuff like that, layout, page, and stuff like that. So it's not good. So that means that you have to create those files in JS and import. If you still want to write the logic itself in ReScript, you have to import the content of this ReScript files. I don't know. I don't have, sorry, but I don't have any good solution for this. I don't know what we could provide. But right now, I think this is quite of a pain. So we should probably think about something that solves this issue. And another issue that was very unexpected is the fact that Next, for some reason, can't find components that are inside submodules in ReScript from a server component. So fortunately, Florian also came up with a solution for this. We have a PR that is ready for review and even ready for merge, I guess. But it's also a breaking change. It changes how components, React components are exported in JS. So it is a breaking change. And yeah, I guess like this retreat is probably a good time also to discuss this and see if everybody is comfortable with this. Okay, and one last thing was dependency tracking. So basically, the cool thing with Shadcn CLI and ecosystem in general is that you have to, for every component that you provide in your collection, if you wanna, okay, let's say you wanna import, I don't know, I have no idea, maybe like something like a card, and inside a card you might use some other Shadcn components. Well, you can actually list the dependencies of a component. So if you want to import card, it will import card, but also all the dependencies of card. So that's pretty cool. And I obviously didn't want it to be a manual because, well, it's very error-prone and very easily you can introduce new dependencies and forget about listing them. So I first thought that I could just analyze the imports in the generated JS files, and well, that works, but that doesn't take into consideration that sometimes you don't import JS runtime things, but actually just pure ReScript types, for example. And this would not be in the generated JS file. So I fixed that by analyzing the .ast file that is generated by the compiler from a ReScript file. And they list this AST files list the dependency of the given file. And so that worked pretty well. You actually need both because like sometimes if you write purely bindings in a ReScript file, the runtime JS dependency would not be listed, and the other way around for the ReScript types, you do need to also analyze the AST. So if you combine both, it works. It's pretty good, but I think it's definitely something that we should provide for, like in maybe ReScript tools for library authors, because that's pretty powerful, and that's really cool. And I know that there are some already implementations that exist, but they are not that easily usable right now. So that's something we should do. And yeah, for the wrap up, so I think it was a pretty interesting project in itself, but that also opened my eyes on other projects where we could reuse the existing ShadCN CLI, because actually ShadCN is, even if it was originally created for components, you can pretty much use it for any kind of resources. And I think a great fit for that would be to have a collection of bindings in ReScript, because I think we have the same constraints basically. Bindings evolve a lot. You usually want to customize them. So I think that would be a great fit. Like you could just import just the parts of the bindings you want. I don't know. Let's talk, for example, about I don't know, if you wanna bind to AWS SDK. It's a huge API surface. With this kind of stuff, you can just import the things you want, and it will auto-track dependencies and stuff like that. So I think that would be pretty cool. And if you want to change things slightly because you're not very happy with the ergonomics of the bindings that were provided, well, you can just customize it yourself in your code base. So I think that would be a pretty good fit for this other very long-standing issue in the ecosystem. That's it. Thanks.
Any questions? Or any remarks?
Yeah, actually, so I was interested in the solution you had for the record spreading.
Yeah, sure.
I think like one of the problems also with this, which is the behavior of optional records.
Yeah.
So if you don't provide it, it doesn't include the key. But if you provide it with the question mark,
yeah,
it creates a key, but it's undefined.
Exactly.
And I also run into this. It's a bit unexpected.
Yeah.
In different places. So maybe, I don't know, like maybe we can make sure that if you have an optional record and the field is optional, and even if you provide like the question mark syntax, that it doesn't include the field in the object, because maybe that would also make this problem go away.
Well, yes, but I guess, well, I don't know, like, do you want to do this for everywhere or just in JS6?
No, like optional records in general.
Yeah, okay.
Because
so
the behavior is weird. Like sometimes it doesn't include the field and sometimes it does.
I know, but then we're back. I mean, this is already a bit edgy, but like, we are back to the same issue basically, is that we don't really have these semantics in ReScript. We have, like, our option type can have only two cases, right? Like it's either none or it's some, and it's the same for optional fields and stuff like that. We don't really care, but the issue is that in JS, well, you have undefined, you have absent fields, you have null, you have like well, plenty of ways to define the absence of something.
Yeah,
And
but we have semantics that is similar with optional records. If you have a record with an optional field,
it can be
like the
either
key is always
option,
there.
off, or a question mark.
But if you have an optional record,
Yeah.
like I think it makes sense that the field is not there if you don't provide it.
Well,
But you'd want to make sure that if you explicitly pass none, that you would spit out undefined. Because that would break behavior in like some JavaScript and TypeScript APIs, where there's a difference between the key existing, like if I do app object.hasOwn, versus that key equals undefined.
But then you have
an option type.
Yeah, you have an optional record with an option. So you have like either either the key is not there or it's like undefined.
I mean, I'm all for it, but how can you solve it without introducing new runtime overhead?
Yeah, that's the question.
And I really tried. I of course, that was my first. That was the first solution I had in mind because it's more general, basically. But I mean, there is no easy way to implement this. If you have any good solution for that, let's take a look at it. And that doesn't solve the other issue. That is that you do want, for example, like for this kind of stuff, for big JSX, I mean for React elements, React components that have a lot of props, you still probably don't want to list all of them. So you still want a way to say, okay, so this is not such a great example probably because like class name probably exists in this component, but you could be, it could be like some kind of specific prop that doesn't exist in the child component, and so you want to make sure that you don't provide this prop to the other component, to the child component, and plus it would not be the same type anyway, so it would error. So you still need a way to do that, I think. But I agree with you that it would be nice to have something for optional fields.
All right. And I think we have enough time to discuss this later. We'll now move on to our last talk of today, Bernardo. So let's set things up. And while we're doing this, I want to remind everyone that we have great sponsors. And especially, I think we didn't really highlight much, especially for Chain Street, they have a lot of very interesting topics you can work on. Like they're looking for compiler engineers, they're looking for people that work in the AI space, especially in the tooling space where you can build AI infrastructure, can be distributed systems, can be coding from your phone and stuff like that. They have a lot of internal tooling there that they want to build out. And they basically own the whole stack starting from the programming language, which is a variant of OCaml actually, or a more specific, more custom tailored version of it. OXCaml, just to pronounce it correctly. And they're looking for lots of talent in London, in New York, in Singapore, and in Hong Kong. So definitely check out the website if you're really interested in this kind of stuff. Yeah, and I guess we can hand it over to Bernardo. I will make sure that you have the right. Yeah, all right. Then let's give it up for him, and I will let you know once you can start.
Is the microphone all right?
It is all right, yes.
All right. Hello, everyone. I'm Bernardo, and I'm honored to be here to spend these days with you all. I also want to thank you for the opportunity to share a little bit what I've been working on the past 6 months, especially for an audience who's very much expert in ReScript. So yeah, I'm here to talk about ReScript Signals and Zolt, two libraries that I've been working on. And yeah, Before, just a little bit about myself. First time I'm meeting you all. I'm originally from Brazil, moved to Amsterdam, where I made my home for the past 8 years. I work as a staff software engineer at BetterUp. It's a company based in US and Europe, where we help organizations to grow and retain their workforce with behavioral science. We don't use ReScript at work. I have never worked professionally with ReScript. So that's why I like to say that ReScript is my hobby language. And don't take this wrong, like this is the best compliment I can give to a tool. Because from any tech, I actually picked this one for my own pleasure and because I believe it's the best tool. And I take my hobbies very seriously, I guess. And I've been following you guys for quite some time. I'm maybe just a bit shy, but I think this was like one of my first contributions to ReScript, and it was like 6 years ago. Probably my most valuable so far. It was just adding ReScript to, not just, but because it's cool, but making ReScript available in identifiable in platforms like GitHub and GitLabs. And that was 2020. So I've been following you guys for some time.
This took some time to actually get through, right? Like because it's relying on GitHub employees to sign it off.
Yes.
It was quite interesting to see how this works.
Yeah, me too. Yeah, it was very interesting learning the process there. And yeah, just to give a bit of context, my history with Signals begins at work. We had to solve a fairly complex application problem with its state layer, which was very tight coupled to the UI. And the solution came with Signals in a successful refactoring. The state became much more predictable and easier to reason about. And the experience got me curious. I wanted to just learn. And in order to learn, I decided to implement from scratch. And I also used an excuse to come back to ReScript. So I decided to write the primitives in ReScript. Also, I borrowed and learned a lot from different sources, but these three were my main three sources. Many things borrowed, sometimes even copied. So the TC39 official Signals proposal, Preact Signals, and Solid.js. But yeah, as a result, two libraries were born. ReScript Signals, the reactivity runtime based on the Signals primitives, and Zote, which is a user interface library that is powered by it. In fact, Zote came first, even though ReScript Signals is the foundation. But I started writing everything all together in Zote, and then Christoph suggested me to extract. And then I extracted Signals, which made much better to actually work and optimize the Signals implementation there in a more isolated way. So yeah, Signals. If you are familiar, Signals is composed by three primitives. We have the signal, which is basically a reactive container, the reactive value. It's our state. We have a computed, which is a signal, but derived from another signal, and an effect. You can see these three as directly a cyclic graph, and where the signals are the source, computed intermediate nodes, and effects are leaf nodes. And yeah, let's take a look first at the Signal API. So yeah, as I said, Signal is a pretty much a reactive container. Here we have the type of a signal. You rarely need to know its structure because mostly with ReScript Signals, you'll be only working with the value. But yeah, it contains an identifier, the mutable value, which is the value that it holds, an optional equality function, so you can use to skip updates in, by default we use a strict equal, but if you have different shapes, you can have a custom equality function. Name is just for debugging, is optional, and the subs, which is internal to keep track of the subscribers to that signal. So yeah, but like these are some common operations that you can do with signals. We have make to create them. Get. This get is the. By the way, if you're familiar with signals or Preact signals, it's pretty much the same API. So we have get. Get fetches the value, but also register to be watching for any changes. Pick also fetches, but it doesn't register, so it only evaluates once. We have set and update to update the values, and yeah, update just accepts the callback function that receives the current value, so you can update based on the current value. And batch, where you can pass a function, and you're gonna, if you update signals in it, it's gonna batch all of them, and then computed and effects will only one after after the batch is finished. Moving on to computed. Computed derived signals, they are the intermediate nodes of the graph. They are lazy in cache, so they only recompute when read, and only when a dependency changes. State dependency edges are cleaned up automatically on each recomputation. So this way we don't have like any risk of leaking. And we also have a dispose function that you can use to manually dispose it. But if you integrate like this reactivity model in a system, you rarely will need, unless you're doing something slightly wrong, I guess. For effects, effects we have two functions, run and run with disposer. Effects are the leaf nodes in your reactive graph. We run them to produce side effects. So every time signal changes, then the effect is gonna be run. So yeah, it's gonna be run whenever the dependency changes. You may also return a callback that is run before each re-execution and also on disposal. And yeah, the run and run with disposer, like I separated here because similar to computed, you will rarely need if you are integrating well. So run is the most, should be the most used operation for effect. But in case you need to dispose, manually dispose, you can use run with disposer, which returns a disposer. Not going to spend too much time here, but because it's not like public, but most of the complexity, or yeah, most of the complexity indeed, is hidden behind the schedule module. This module is the one responsible for putting everything together, connecting signals, computers, and effects. It decides when things recompute, in which order will things happen, and is the module that tracks that who depends on whom. And that's it about signals, really. But all right, what if your effects are DOM manipulations? So that's pretty much how you can power a user interface library with signals for the web. So the DOM manipulation becomes a side effect of a signal update, whether it's a signal or a computed signal. The updates in the DOM becomes then surgical by default. So we don't need like virtual DOM, you don't need to diff. And yeah. So it also supports JSX, so you can build the UI in a declarative, familiar way. I'm using the JSX from ReScript with a few things that I put on top of it to integrate better with signals. It has a built-in router. It's a simple but functional router. A server-side rendering is still experimental. The DX is not so good, but yeah, but it works. And yeah, and we also have an ownership system where effects and computers are disposed when their owners are removed from the DOM, which is something that Christopher sent me analysis today. we might have something to improve there, but something that I will be taking a look later. And that's the node module from Zote. This is like in this module, that's where we're gonna see most of the functions that we're gonna be needing to build user interface with it. Here you can see the type. It can be any of these types. Can be a simple node text, that's a DOM text node. A signal text, which is a reactive DOM text node. Then we have fragment, signal fragment, keyed list for list reconciliation on updates. No need to worry about that, but let me go through it, the most common functions you'll be using. So as I said, like these are static, just used to render some variables you want to render in the DOM. But then you also have signal text, signal int, signal float. All of them in the end is like text nodes, but it's just a more easier way to so you don't need to cast the types when using them. We also have the signal fragment that's gonna like replace the whole DOM fragment when a dependency changes. And yeah, list, key list. We also have the same for HTML attributes, but if you are using JSX, we already like do this for you, so you don't need to worry about using signal attribute, for example. And lastly, we have the functions to mount in the DOM. This is a very simple example of a counter. I think maybe it's the third or fourth counter example we are seeing, which is good because then it should be familiar. But yeah, if you see this, might look even like a React component. Here we have a count, a signal count with 0, a double that's going to be updated and with the double of the count value every time it changes. Here we have an effect that's going to print every time the count signal changes. And here how you use in the DOM, how you render them in the DOM. So you have here signal int. You also have like for signal text, signal float, and so on. Update and set. Yeah, that's pretty much a very simple Zote component, how you would define. And maybe I thought about having a demo, but actually this whole presentation is the demo. So I needed like a slides. Yeah, probably this is like biggest rabbit hole, right? Like you need like, oh, I need to do a presentation. I need to do a demo as well. So I'm gonna do like an app so I can build my slides in it. So yeah, I built a slide editor, or Claude built for me actually. But it's very functional. It has everything, routing. You can create new decks. And I thought it would be also a good example because it has a lot of like interactivity in it. But yeah, you can create headings, edit. Something that I always wanted is a grid in slides. So, and snap to grid, so it snaps. Yeah, even font, alignment here, flexbox, everything, yeah. It's its own only client-side application, but I'm persistent using IndexedDB, and you can also even like export the JSON or export as PDF. So yeah, also we can present it. So yeah, I'm loving that we can do this kind of things nowadays. And let me just come back here. Yeah, the tech stack that I used for it was ReScript, Vite, Zolt, and Tailwind only. Another thing that I was very impressed, and I think this is I owe a lot to ReScript compiler, is the bundle size. Oh yeah, network. I'm in the right one. So how much do you think it would like? Can you give a guess? Don't say like 2 or 3. Okay, wait, please.
7.7.
7.7.
50.
All right, like that's no, it's actually like 29, which is not bad really. It's really not bad. And
29K for thoughtful.
yeah, yeah. Performance-wise, it's been very nice as well. Of course, this is like only client side, but I deploy on GitHub page, so this is you can access, you can play with it, maybe to give to your next talk with it. But yeah, it's been I did like over the past few days before the retreat, just feeding prompts to Claude, and it was great really. A very nice experience. Like I didn't have like many errors, no runtime errors like during in all interaction. Actually, I did have because initially it was using a lot of like raw.js, so I just asked, hey, put a rule there to not use. If you need to use, then generate a binding for it. And yeah, I didn't have any runtime error. The only thing was doing like it was only yeah, we would call it like business rules bugs only, which was great. And let me see. Yeah, you can find this is the ReSlides. I gave the name ReSlides, and I'm using also the same color palette, so I hope it's all right for copyright. But yeah, feel free to check. And here is the repository for Zolt and ReScript signals. And maybe just one more slide. Just say thank you. And yeah, I think that's it.
Thank you so much, Bernardo. I think this is something we, like every time when we're talking about programming languages, like there's trade-offs, right? You decide, okay, is it good enough if I just use TypeScript, or is it good enough if I go with plain JavaScript, or should I use like something like Rust and compile to Wasm or whatever? And I think the underrated part or the underselling part is with ReScript, when you build something like a super interactive application that is like having a lot of different, because you're talking about a lot of states and a lot of like states that should not happen, right? And this is very hard to design in TypeScript. So I guess this is the prime example of, oh, you don't want to build this in pure TypeScript because it's just going to be messy. And there's going to be a lot of like edge cases that you will not be able to cover, right?
Yeah, exactly, yeah. I was already very happy like with ReScript, and even though I don't work my day-to-day with ReScript, I have such a joy working with it. And now with AI, this is like just amplified, I think, because you can do much more. But we're having the right constraints in place and having a fast feedback loop, it's very important. And I just I'm having like a blast with this. And yeah. And I think the future is very interesting. Another thing that I wanted to maybe leave in this talk is that we can do pretty cool stuff with just ReScript, like having like ReScript first mindset. And I'm not saying that we should ditch bindings at all, because that's how we can interact with tools that are very good and very battle tested in the market. But we get so much when we just like remove a bit of this extra layer of abstraction between like with the JavaScript world and the bindings. You just decreasing complexity. It's good, and it's good also for agentic work as well. So yeah, I think.
And this is also like so interesting because like I can remember 2017 I was like attending a React Vienna meetup, and there was this one person from Lower Austria I've never met before. Like he was, I think, even like the first time he went to a meetup, and he was like, "Oh yeah, I tried out Elm, right? Like this pure functional language for the web," and he also rebuilt Prezi, like this very, very visual presentation kind of tool, and this was always like this was probably my personal like, moment where I said, okay, this stuff is really, especially if you can guarantee that there is no runtime errors. But having with Elm, it's still like the interoperability is still a problem, and this is oftentimes the deal breaker then in the end. Like you still want to have this very easy way to interact with the outside world.
Yeah.
Otherwise, it's what do you do if the presentation wants to interact with a server? What if you want to sideload some, like little widgets that can only be done with a JavaScript library you care about? So in this case, I think, I like the idea. It's just we have both of the good of both worlds basically, and that is the key aspects where I really enjoy ReScript. Thank you so much for this presentation. It was really cool.
Thank you.
Just checking the chat 1 second. So there's one question. Does Xode have built-in stores for state management or some other library?
Sorry?
Does Xode have some built-in store for state management or some other library? You need to enable your microphone again.
No. It's still pretty new.
Press again. Yeah.
Yeah, can you hear me?
Yeah, for some reason the bottom button. Here's some. Or take this one.
Yeah. No, like we don't have like any really like solutions for, or at least not yet. Feel free to.
Yeah, go ahead.
Yeah. Like signals are already like it's more like a reactivity model. You can build custom things on top of it, and then but no, what like Xode, it's pretty much what I showed here. You can build more abstractions on top of it, and I encourage that. But yeah.
Yeah, and also thank you to Atzik Profit for interacting with us on the chat. That was really cool. Alrighty, then we'll close down the stream now. Thank you everyone for watching, and yeah, we'll definitely, like I can imagine, like next year, most likely going to be another retreat if everyone is keen for that. So stay up for that. Follow us on Twitter. X. I think we also have a Blue Sky channel. So yeah, we'll post all the information. We'll also post all the links and all the descriptions of the talks from today. So yeah, thank you everyone, and see you.